and then you will be having a word, let's say A, B, C, D, any string will be a word. Now you have to find if it is possible to construct this specific word which we have, and it should be sequentially adjacent cells. It should be inside the sequentially adjacent cells in my board. What they mean by sequential adjacent, as you can see, A, after that we have B, after that we have C. So all of them are sequentially and adjacent. Now adjacent also they have defined what adjacent they mean. They mean horizontally and vertically neighboring, because adjacent can also be diagonal ones. So they actually mean horizontally and vertically neighboring. That is what we want. Now if we come back and if we had seen a similar kind of problem, like if I modify the problem and say you that, bro, imagine that you have no word, you have no sequential ordering, you have nothing like that. I'm just saying that as part of the problem, which means you are just given horizontal and vertical neighboring cells. That is the only thing. Let's say if you are given and you have to find out if you have word, let's say if the word is all of the same characters itself, let's say A, all 6 times I have A. Now I ask you, is it possible for you to find this specific cluster inside this? And this should be horizontally and vertically neighboring, which means entire chain should be actually neighboring to each other. Then what you do? Usually what you do, you just simply have, okay, Aryan, what I will do, I will start off from any cell, okay, let's say this cell, and I will simply apply a simple DFS traversal. I will try to go, and again, my DFS traversal condition is only if the character is actually A, which is, let's say if this would have been, rather than word, if it would have been a character only, character C is equals to A. If my character is only A, then I would be simply going on and doing a DFS traversal. Sorry, up till here itself. Okay, let's keep it. So I will simply do a DFS traversal, and then simply will give me, okay, bro, this is the length which I have after doing a DFS traversal. This is the maximum length I have, and you can just take that length. Or maybe if the word would have been all A's, I would have compared that DFS length, because you know by DFS you can find the component size, so you can easily go and find, okay, bro, this is the length. Again, there are slight catches, because component will end up actually going very big also. Maybe if the A would also have been here, so he would have also gone here and here. But again, I have left the part that it is sequential. So right now you can just imagine that I'm just trying to see what all A's are there in my actual matrix of this board. Now this is complete. Okay, I can simply solve this part of the problem in which I have to just go on to neighbors. I can simply solve that by a simple DFS. But can I solve this by simple DFS? Maybe, maybe not. Let's see if we can do it or if we cannot. Now, if we come on back, so we realized that in a simple DFS, how a DFS function looks like is that, okay, return type depends upon what you want. Initially, let's say it is void. Now you just write a simple DFS. Now, as it is a matrix, so you have to go to next cell, which means, let's say I'll give int I and int j. That is how a simple, okay, wherever you have to go. Again, you will have to pass in boards and visited maybe also. So that is again things which you will write for sure. I'm just writing the main arguments. And again, here you will just in the very beginning check if your actual cell which you are going on to, it is valid or not. So how you check that valid condition? If your I is more than or equal to 0, or sorry, if your I is less than 0, or if your I is more than or equal to n, or if your j is less than 0, or your j is less than or equal to m, then you simply say, bro, right now it is not possible to go beyond. So you simply end up returning from here itself. Again, our condition is void right now, so I'm just having a simple return, but depending upon how we change, we will change that. And in a simple DFS, then what you do, you will say firstly, again, so as to not go into infinite loop, you have to mark that as visited. Okay, bro, visited of this cell I comma j is actually a true. So you also keep track of visited array. Here in this case also, that if something is already visited, you just mark that as true. Okay, if something is already visited, let's say visited of I, j, if it is visited, then you simply return from here also. And then when things are done, you just simply go on and say I plus 1 comma j, or I can do a I comma j plus 1, or I can do a DFS of I minus 1 comma j, or I can do a DFS of I plus I comma j minus 1. Now these are the 4 directions I can actually suddenly go to. If I am at the cell, I can go to top, right, left, or down. This is a cell which I can go to. So this is how your simple DFS looks like, right? And now I know, okay, maybe something like this I can actually use. Now let's see. The only thing is I have to keep track. Okay, Aryan, earlier I was just going on, I and j. I was going on to I and j. Okay, initially my I and j is here, then my I and j is here, then my I and j is here. But right now I have to also parallelly take in focus the word. So if I am in the very beginning at this I and j, I will say, okay, I am at the index 0a. So now I will also have to keep in consideration this specific character A. So I will have to, again, earlier I will have to pass in the board vector because of I will have to go into board vector, so that is for sure. I will have to pass in the visited vector also because to make sure if things are visited. Now with this condition I have to pass in this word string and also the index of that string, because if I am at the first cell, okay, that is the cell ij is the cell of the matrix, but I need to compare with the word character which is specifically right now a. Okay, I'll compare that, then I will move on. Again, to move on I have again parallel options. Again, although it cannot go up and left, but still it can go right and down. So I will try for both the possibilities, but as you can see, firstly, let's say I tried for B, or maybe I can try for down. Let's say if firstly I would have tried for down, then it would have compared the character S with the character B. This is not same. So I would have returned from there itself. But return what? I wanted to know if things are possible or not. So one thing I got to know that I will change my function and I will say, okay, now I need to know if things are possible or not. So, okay, let's name it as bool. Okay, then Aryan, but you did not tell that how will you call this function? Bro, we'll go on to that, how we will call this, all that stuff. But let's see, if let's say our DFS call is, let's say, starting from this cell. Again, this cell can be 0, 0. Let's say it starts from this cell itself. Then how I will go about it? So I realized that I would need a word, I would need an ID of that word also. Now, in what case that you will end up saying, okay, bro, I am done. That is the condition when you will say, again, here in this condition you will have to return a false, because now it is not valid. Now I'm changing depending upon what I am returning, I'm changing it to false. Now I have to also make sure when it is true. I have to also make sure when it is true. Maybe now what you can do is, maybe you can just put a return condition here itself, or maybe you can just say that put a return condition here itself. So you have to see where you will have to put condition and what condition you have to put. Now by a normal fact, I'm just analyzing that what will happen is, when I will return true, when I know that my entire word has been completed. So either the condition would be that if my id is equals to word dot size, then I would maybe return a true, or maybe again depending upon how I'm implementing, it will be either id is equals to word dot size minus 1. Depending upon how I'm implementing, then I can return a true. Minus 1, then I can return a true. Again, Aryan, how are you saying this? We will see that. Again, I'm just telling you that it entirely depends upon what you return, but the fashion is still the same. Now let's come on back. Okay, I will mark things as visited because I'm visiting that stuff. So it seems completely fine. And then I will have to go and check that, bro, if you go on to any character, let's say if you're going on to B, let's say if I was, let's say at I comma j. Okay, let's say imagine it matched, but then I'm going on to, let's say, this cell. Again, this is something I dash j dash, but it is right now I comma j plus 1. So what things I have to consider? First thing is that, bro, if you were at I comma j and it was valid, okay, it was valid, so it was visited. Okay, you visited that. Again, it was valid and then you visited it. It was valid and then you visited it. So now in this case, you are trying to go to I comma j plus 1. You have to first check if your j plus 1, again, it entirely depends upon how you implement it. I'm just showing you one of the implementation. You can make it short also, depending upon what you like. Now, first check is that you can't go and just simply go, and again, you have just verified that I comma j was valid and you just mark it as visited. That's completely fine. Now, again, this might not be required depending on how you implement it. Again, I'm saying that. So right now, let's say if j plus 1, if it is less than your m, right, and it is not visited also, it is not, because I have told that I cannot visit things again and again. The same letter of the cell may not be used more than once. So I cannot use that again and again. So I know that I comma j plus 1 should not be visited. Let's say not and false. And what? Okay, the character should match, which means this character board of I comma j plus 1, it should match with the word of ID. So I'll just simply say that, bro, board of I comma j plus 1 should match with my word of ID. Again, word of ID, it should match. So this ID which I am passing, it should actually matching. But Aryan, in this case, when you were saying that you were passing in your ID itself, in the very beginning you will pass in the ID as 0 or a 1. So it can go a bit confusing that what actually you have to pass in the very beginning itself. So let's hold on from here and to analyze, because see, indexing and stuff, these stuff can go a bit confusing depending upon how and what we are passing from the main function. So from the main function, I just want one thing. I just want that I should call a DFS function saying that, bro, starting from cell 0 comma 0, I am saying starting from cell 0 comma 0, and then I will pass a board visited, I will simply pass, and then I will also pass my word, and then in the very beginning I will pass my index ID as a 0. Okay, so if I am saying that I will go to I comma j plus 1, so ideally I was at I comma j and I have to go to I comma j plus 1, so I should compare it with the next index. And that is the reason, if I'm comparing it with the next index, I know I am actually saying that next index is actually, I'm matching it with the I comma j plus 1. Then I can actually and simply go and ask, bro, okay, ask for the remaining indexes. So I'll simply go and ask my recursion saying, bro, I comma j plus 1 was perfect, and then okay, board, word, and all that stuff I will pass in, and then okay, next index, because you remembered you have passed an ID here, so you will pass an ID plus 1. But the strange or the best fact about what we implemented is that right now ID plus 1 is actually valid. This I have matched already, and also if we are actually accessing ID plus 1, so if ID would have been word, if ID would have been this here, so ID plus 1 would actually give us null. It would actually go beyond the indexing. So if I would have not, like if I would have stopped not here, and if I would have tried, okay, maybe let's just stop at ID when ID becomes word dot size, then for sure when ID would have been last index n minus 1, then it would have gone plus 1, then I would have gotten a runtime exception. So from the implementation which we are trying to do, it seems like that I am trying to actually validate, only then I am going on to that index. Firstly, I am validating that index, okay, that index is good, and then I am going on to that index and further on. So when I am onto this ID, I have validated that, okay, I comma j is in line with this ID. I comma j is in line with this ID. So for sure we don't require this line, because I know I comma j is valid and it is also in line with the ID itself. So I can just simply remove this. Again, you can also keep this line, and you can just maybe remove this part. That's totally up to you how you implement it. Now coming on back, that we realize that we cannot put this as the end condition as in the return condition. So we'll just simply put in that, okay, if my ID has reached the end, because we have validated this ID has already been validated, so it is good. So if ID is equals to word dot size minus 1, then I can simply return a true, because I know that I have reached the super end. And also we know that, okay, we will mark something as visited, and then we can simply go on and try on this specific value. Okay, if index is inbound, if it is not visited, I will just simply check if the correct is matching, and then I will try for the later DFS. Again, this DFS will return a true or a false. That's the reason I put an AND condition. Everything should be correct, and the same way I'll do it for everything. Now I'll ask you, is this correct? Maybe, maybe not. Let's see. So far we have just analyzed one example, and from that we have made 90% of the code. Now we might end up missing some cases. First case is that, okay, you have, let's say, SEE. Earlier you were starting from index 0, 0, but for sure if you will start from here, never ever you gonna reach anywhere because the first character itself is not matching. So one thing is, I cannot start from here. I can start from here, but then I see, okay, it is again not matching. Then I cannot start from anywhere else. I can start from here itself maybe. Then I can see, okay, it can give me answer. So I realize that my starting point also can be any of these. Again, this is the n cross m matrix. So starting point can be any of the point in this n cross m matrix. So I realized that, okay, in my actual function, I cannot call, in my main function, I cannot call DFS from 0, 0. I have to try calling my DFS function from all the possible valid cells. And valid cells for me are, I'll go and iterate on my ing for int I equals to 0, I is less than n, I plus plus. Again, I usually keep I as n and j as m. You can just change it by yourself. J is equals to 0, j is less than m, and j plus plus. Then I realized that, okay, bro, simply call DFS function from I comma j, and again board will still remain same, visited array will still remain same, again that's an empty array, word will still remain same, and index I will simply pass in 0. But if you remembered, what we were doing right now is we were saying that, okay, if I am passing on an index, that is actually valid. So if I am saying I comma j and index 0, which means that board of I comma j should actually be equal to my word of 0. Only then I will call this DFS function. So I'll just put this if condition right here, and I want any of the I comma j starting cells. If it actually satisfies my word, like it gives my word, simply return the true. Return true. I can simply put my here, return true here itself. So you will see that in my main function, I'm trying for all the ing combinations, and then I am checking if any of the ing, starting from any of the ing, if I can get a true, I will simply return a true. And if not, then I can simply return a false in the very end. In the very end, in this, after this two for loops, I can return the false itself. Return false. Now, Aryan, okay, now from this example, we realize that we have to go on to all the n into m cells. Now, okay, let's see. In this, you can see that no, okay, you have A, B, C. Okay, then there is no B. So, okay, A, B, C, then there is no B. Okay, this is also gone. Then you are seeing that you are kind of going and visiting stuff, and then when you realize that, okay, it is not there, you just say, okay, it is not there. Now, I will give you an example. Just look at the code what you have written so far. Again, replicate this exact same code for all these three conditions. Again, you can just also summarize this and put it above also, but a slight things will change. Now, if we realize what we have written, let's quickly try it and see if it works or not. Because if you will go and implement this right now, it will actually fail because it is missing one thing, which is that you have remembered that it can not necessarily be valid for you to actually get a string. Maybe some other path gives you a string, some other path might not. What I mean by that is, by your code, you will simply start from a cell, I comma j. Now, okay, you can start from this cell itself. You will go on to a cell, then you have multiple things. Okay, you can go to all these adjacent cells, I plus 1 comma j, I comma j plus 1, I minus 1 comma j, and I comma j minus 1. And so as to not visit those cells again and again, you are marking things as visited. Okay, great. So you go from A, then you go on to B. Again, as you move from A to B, you have marked A as visited. This is visited right now. Okay, great. Now from B, again, this is your word string which you want ultimately as your answer. Now from B, you can move to C again. That is, again, you have also marked it as visited. Now here also you moved. Let's say you moved and you went on and said, okay, this is also visited. You have marked as visited. Now you went on again. Let's say again you try to go on to E. Then you marked it. You marked it to D. Let's say this is G and this is F. So then from E you try to go on. Okay, G. You marked it E as visited. Great. Then from G, again you can see E and after that G again, good. Then you mark G as visited. Then F is not matching with H. Then what you will do, F is not matching with your H, then your code will say, okay, index is valid, it is not visited, but your board, it is not matching with what I wanted. So what your code will end up doing is, okay, return back and try for a different possibility. You return back and you try for a different possibility. So what you end up doing is, firstly, you have tried for this cell, then you will try for this cell. Again, that is also not a H. You will try for this cell, it is visited. You will try for this cell, it is visited. So what you end up doing is, okay, sorry, my cell is gone. Yeah, what you end up doing is that, bro, from G I'm just stuck, I cannot find the H. So ideally what happens in recursion is it simply comes back. So yeah, sorry, it simply comes back. It comes back to E, and then it will again trying to find, okay, it comes back to E, and then it will again try to find what I can find. So it will again go, okay, this is visited, so it should ideally not go here. Okay, it will not go here. Then it will go at next G. Okay, it is not visited. As you can see, it is not visited. Let's change to G. Now it is not visited at G, so it will go an H, again not, okay, I, okay, okay, J, okay, and then you can see, okay, right now you are at J. This G, ideally you visited it way before, but while coming back, it is still visited while coming back, because if you remembered, you went on from E, G, F, but then you realized it is not a good path. Then you came back, you were at E, then you went on right and then came back to this G again. But ideally, if you go and look for, then this G is visited, so you will not end up visiting it, and you will say, bro, it is already visited, so you cannot go here. J will never be able to go at the G location because he will see it is visited. That's an issue, because you realized that I would have made A, B, C, D, E, F, G, H, I, J, G, J, G. This would have been my string word which would have matched, but because of one of the routes I have already marked something as visited, I cannot mark it as visited again. So what you realize from here, you realize that a concept called as backtracking is very important here. Backtracking simply says is, if you are going somewhere, okay, if you come back from there, if you realize it is your mistake, you have not found any good path from there itself, and if you are coming back from there, please, bro, mark things as not visited, remove them visited also, remove the visited also. So what you will do in your code, simply one thing, that when you have realized all your path sucks, then in the end you will see simply say one thing, bro, I marked my ing as visited, I realized all of my path sucks, I will simply backtrack. Again, backtracking as in, again, DFS internally backtracks things, but manually for us, when we say backtracking, only when we actually perform an action while returning back. That is actually called as backtracking for us programmers. So I'll do a simple modification and I will say that visited of I, j should be false. If I have realized that all of my tries are waste, I cannot go anywhere, so while returning back, I should make things as false. And ultimately you can see that if things are valid, which means if you can go on to correct cell, if it is not visited, if you are going on to a board, and if you have to do a DFS, and if things could look, then you can simply return a true from here, because DFS itself will actually say, okay, the remaining path starting from I plus 1, id plus 1, if things are good or not, and ultimately you are trying for all the possibilities. Make sure that. Again, Aryan, what if you are checking visited here and then you are reversing? That is the reason, bro. This visited is while I am going to a path, for sure I should make sure, as you can see, while I am going to a path, I should make sure that previous things I should not go and visit. Previous things I should not go and visit. This visited at a false says to us that, bro, while coming back, I know I have exhausted all the possibilities, and while coming back, I should make sure that this is no more, I no more used it, because I came back from there itself, I no more used it, so please mark it as false, so that you can actually use it again in the future. And as you can see that if things are valid, you are returning true. If things for sure in the end becomes not valid, you will have, because here you are returning false, because everything was screwed up for you, so you will simply return a false from here itself. Return false. Now this is your code which you end up getting from these three examples. Now that is a simple code, but Aryan, what is the time complexity for this? As you can simply see that you will call this DFS function for n into m times. Again, n and m are the size of the matrix. Now you call this DFS function, and that you can see it's no memorization, it's a simple recursion. So what all can, how many places can it go? One thing is, okay, n into m is for sure there, then you are simply calling this, you are simply calling this DFS for this n into n times. Each DFS call, you can simply see that it will go on to these 4 places. So Aryan, are you saying that it will be n into m into 4 raised power? Because again, from every cell I have 4 options to go to, and from every cell I will again have 4 options to go to. So it will be 4 raised to power something. Now something what? For sure, I will go up till I exhaust my ID, right? So it will be raised to power ID. ID is the length of the word. So I'll just simply say word. Ideally, this should be what you might end up thinking as a time complexity. But if you go on back, you will simply see that this complexity, if I say n into m into 4 raised to power 15, n is 6, m is 6, 4 raised to power 15, it's high. If I show you 6 into 6, let's say 36, multiplied by, it is visible, right? Yeah, multiplied by 4 raised to the power 15. This you can see it is very high. This will not work. But Aryan, are you saying this question will not work? So how I will do? You just missed, bro, one thing. Now, as you can see, what it says, this portion says that n into m is actually what all? Okay, from every cell I have to go and do a DFS. This is the DFS time complexity. Base says I have 4 options to go to. As I can simply see, I will have 4 options to go to. DFS of this, or this. But ideally, if you go and check from any cell, if you go on to any other cell, from this cell, or let's say any cell, let's say this cell, if I go on to next cell, okay, next cell, this, Aryan, as you can see, I have 4 options, this and this. Yeah, true. That is only for the first cell you have 4 options. For other cell, let's say from C onwards, you have at max 3 options, here or here or here. That is the reason. From only for the first cell you have 4 options. For every other cell you will have 3 options. So ideally I can change this entire thing as, for the first cell I have 4 options, for all the other cell I have 3 options. That's it. So this is how things can go. So this would be a time complexity. Now again, in bigger terms, this would be 3 raised to power L. Let's say L is the length of your word. But still, if you go and again check 4 multiplied by 4 into 3 raised to power 15, still it is high. What we are missing? We are actually missing what is actually happening, because as we will go on, again, that is just a brim, like in the brim, like at the brim itself. If you remembered, we are doing a partial pruning already. What is pruning? Pruning simply means, again, if you had gone and looked at the follow-up question, it simply says, can you improve the search complexity by simply using a pruning? Although the constraints are not that much big, that by the simple example itself, by the simple complexity itself, you will still end up passing that. But I will still help you improvise it much more further. How? First thing is that the code which you have done, which I have told you right now, it's actually already doing pruning. Pruning is simply saying, if things are not good, never go there. If things are not good, never go there. Although you would have got rid of this condition on here itself, or we can get rid of this condition here itself, that if anything is not matching, bro, simply return directly. Don't even go at that location. So that is how your pruning helps you. So you can see that we are actually writing a very optimized code so far. And also, but Aryan, still I didn't understand that how will this complexity works. This will work because you will see, as my length will keep on decreasing, as, okay, if I have in the very beginning, I started from here, I had 4 options to go to. Here I will have 3 options. Here I will have just 2 options. Again, here I will have just 1 option. Okay, 1 option. So you can see, this is not 3 raised to power L. Exactly, it will be, okay, for 1 it will be 4 into 3 into 3 into 2 into 2 into 1 into 1, and so on and so forth. So it will be 3 into 3 into 3 into 1 into 2 into 2. So it will be very much less than 3 raised to power N, 3 raised to power L. That is the reason this will pass for you. So this is how we will actually end up doing this. Sorry. I just missed you one thing. It will be 3 raised to power 14 because 1 you have already done. So you can see it is 1, 2, 3, 1, 2, 3 and 1, 2. It is 6 into 10 raised to power 8. 1, 2, 3, 1, 2, 3 and 1, 2. 16 times power 8 nearly, which is 7 times power 8. All this is still high, but it is saying that it will be 3 to power 14, but it will not be like that. It will be very less because your future ones, because 3 to 14 says I have multiplied 3 14 times, but that is not the case. Your 3, this will actually be reduced to 2, 2, 2, and for the last 3's it will be reduced to 1, 1, 1 because you will have no other options. So this will be very less than this value. Thus, it will actually be in like under 10 to power 7 itself. What I have roughly calculated. Again, formula will be very hard to know because it is actually DFS. It depends upon the calls, how the calls are being done. But that is how you can roughly tell. But yeah, again, in the Leetcode, that will be a very shallow explanation. Okay, these are compilation, but people never go on to actual calculations of the complexity because again, if you go in the Leetcode, you will just see the complexity is n into m into 3 raised to the power l. This is what they have mentioned, but ideally for sure this is wrong. Now coming on back, again this is right, like partially right. So we have realized that we will solve by simply doing this thing. Now let's see the code. It's pretty simple, or as what we have seen already, that we will keep R and C as board's row and column, and then we'll go on to all the I comma j, and then I will just check if the board, okay, if that, again, for me, if I'm going on to a specific index, I am saying already that it is good. That is a change which my code has doing. Again, you can implement your code by saying, okay, I will go on to the next and then I will check. That's totally up to you. But you have to change a few things also. Now, I'll go on to the index and then I will just say, bro, it is good. Then I will go on and start off. Now, if I go on and start off, I will simply firstly check if I have reached the end. And again, this index I have already checked. As you can see, I've already checked the index and then I'm going on to the DFS call. So if I am onto an index ID, I've already checked that index ID. Now I will firstly mark things as visited, and if you remembered, if nothing works out for me, I will mark this as false also. That's one thing. And again, what I will do, I will simply check if the index is valid, if it is not visited, if the board is actually having the same character as that of the word at the ID plus 1, because ID I've already checked. I'm checking for ID plus 1, and also I'll just check and go, okay, bro, call the simple DFS for the remaining calls. And the same thing I have done here. It is for I plus 1, it is for j minus 1, it is for j plus 1. This I will try for all the 4 possibilities, and then I can simply return false if none of them returns true. If none of them returns true, I will simply return false in the end. Now, with this code, you can simply see the time I have already explained is O of n into m into the DFS call. So this is actually roughly 3 into length, 3 raised to power length. Again, I have explained very deeply of what the actual time complexity is. But the space you will see, again, you are making this visited array of size n into m, and then you are having this recursive call. If you remember, this recursive call will go at max up till what the ID is. ID is the word length. So this recursive length will go at max to the word length itself. So I know the recursive length will go up till the word length. Okay, word length. The entire recursive call will be the word length. So this is the word length. But you are also having your n into m for every of those, as in for every of those, you will just make it. You will just make this specific visited array, which you will make sure, okay, I can simply keep it. So you can simply say, okay, I made this visited array. So, and for every of those calls, I'm passing this array. But Aryan, why have you done a multiplication? It should be plus, right? Yeah, it is plus, because you will simply make this visited array and then you are actually passing this visited array entirely on this function DFS call. But Aryan, for every INJ, I should make my visited as actual true, as in like it is good to have a true. That is a correct thing. Here in itself, you should actually mark your visited as false and then you can pass it. But here, while returning back, you are already marking things as visited as a false. Thus, that will actually also suffice. So that is also completely fine, and you're actually verifying things and then visiting it. So overriding visiting will not affect you that much, which means which brings to a point that visiting is not playing a very important role. This array visited, which we have made, it is ideally not playing a very important role. Like you can see the code is not exactly correct, as in like, okay, even if ideally what we do is we put visited in this for loop line. Okay, when both the for loops are done, then we'll keep it and then we'll call the DFS call. That is how we had done in graphs also. But here in this case we put in here and still we are saying it is working, because we are saying okay, it is actually overriding it back to false. But what if partially things actually being returned from true itself, which means some answers returning true from itself, but still it will be okay, because we actually first verify things are good and then we mark thing as visited. So if things have not been verified already, it will already be not marked as visited. Okay, things look good, but still doesn't seem like that if we are reverting anything, which means that I can never use this. I can maybe use my board array itself. I can revert this board array also back. This board array, what I have got, I can revert this also back. If I'm just only reverting things, okay, I'm making things and I'm reverting things, it's as simple as that. So I can just use the board array. I can make it something and I can revert it. So I can use the board array instead in place of, okay, let's erase this. I can use the board array instead in place of using my visited array. So I'll just entirely remove the visited array itself. I'm using only board array to mark things as visited. What I will do, I will replace my board array with a star. But Aryan, it is wrong. No, because you are reverting your board array back to your character. You are reverting your board array back to your character. So ideally what we see is, okay, things are reverting back to a character and thus things are okay for us, and when it will go back, it will have all the characters in place what it should be having, and ultimately you can simply return true if things go good and else return false if things are not good. And with this you have like remove the space, which would, like, again, it's okay for you. If you want it, good. If you don't want it, good. And that's how you can simply solve it. Now coming on to the robot cleaner problem, it is more or less same. If I go and tell you, see, although it's a premium problem, but you can just simply see that how things are working in this. Now in this, if I go and show you, there's a robot which you have to go and let him clean. Now in this, the functions, you cannot go to ing, you have these function calls which you have to do. So what you end up doing was you end up calling a DFS. But in the DFS, when you ended up going on to all the 4 directions which you had, you will see that you have to go back. Robot went on, but now it has to come back. Now again, this comeback function is nothing but how robot should move. It is robot will turn right, and then move, and then again turn right. So it is that robot has this phase. Again, imagine this phase as like this phase. So robot has to go back. Now robot can only move like this. So robot, as you can see, robot has a few movement only what robots can do. So in this, robot turned right, then he moved, and now he is in the below cell. Now then he will again turn right, and then he will again his head is pointing to where he has to go. So this is how backtracking, movement to back, will actually work. So this is the only thing which we have to do. That's it. This is how you can simply solve this hard question, which has been asked by a lot of companies. If I go, yeah, a lot, and especially by Google and Facebook recently, a lot. Cool. Again, I want to show you the time which you can actually prevent by, see, this is a time which you will get if you use your board as a visited, and if you use visited only, then you will get a bit more time, then because you are actually using another array. Again, space you will see is a very less optimized, because space doesn't matter that much. If you can see, it is not used that much, but internally accessing that space increases the time. Although time of Leetcode is not much reliable, but still both space and time will reduce by a lot of margin even if you reduce the space. That is a fact which you should know. Cool, bye bye. The video has gone pretty long, but I hope that you guys got it, a very deep crux of how to solve these kind of problems. Bye bye, take care.